Alright, so I know some of you are saying, you should use a video, blah, blah, blah. So, here it is, okay? Alright. And now I'm invisible again. Alright, this is stem and leaf plots. We've made bar graphs, line graphs, and circle graphs. Sometimes stuff doesn't fit because it's too wide apart or there's no consistency. So in those situations, those types of graphs that we've already done won't work. So therefore we have another type in mathematics called a stem and leaf plot, or a stem plot, you'll hear as well. This type of graph may give a better representation to the data that we are trying to show. Okay, so it's an easier way for information that has spread apart data and no consistency. Okay. Remember, if we're talking about a bar graph, we're comparing two things. Line graph, comparing, so that's the boys and the girls concept. Circle graphs are meant to display entire sets of data, not based on boys and girls. And now we have stem and leaf plots. You're not actually going to be doing a stem and leaf plot for your project here, but oh well. All right, so here is the process. We have our stem and we have our leaf. So we've got this black line, so we make kind of a chart, but there's more room for the leaf. Okay, the stem is made up of all of the numbers except the number to the far right. Okay, so we'll see an example here. For instance, in the number 123, the 12, okay, so we're picking the first two numbers, starting from the left, we move in, would be the stem. Okay, notice that the only number that's not part of the stem would be the number 3. In a number like 48, the stem would be a 4. So what that means is the leaf will always be the far right digit of the number. Okay, so as for the example to the left, the 123, the leaf would be 3. For 48, the leaf would be 8. Remember, when writing the leaf, we do not separate them with commas. You'll see that in the example. And we put them in numerical order from small to big. You'll see that as well. One other thing that I want to mention out, the leaf is always a one-digit number. So please make sure that you write that down. Remember, pause, write down the information, and then listen. Okay, you'll need to learn how to take better notes. Some of you literally on a 9-minute video took 3 sentences. Okay, sorry, I'm getting off key, off topic. Okay, so we have the number 4 and the number 8, so that represents the number 48. That's the example that we had here. Okay, so if we were trying to graph the data 43, 45, and 51, we would use a stem of 4 and a stem of 5. So we have a 4 here and a 5. The leaf would then be a 3 and a 5 and a 1. Notice no comma, but we put a little space in between, and you notice that the numbers are in numerical order from small to big. So the closer we get to this black line, we should get smaller numbers. Okay? And then the last thing we need to do, just like you did for double bar graphs, double line graphs, is you have to explain what it represents. We call that a key. Okay? So for this one, I would write my key. Now, the key does not have to involve the numbers that are written, but it can. So let's say I wanted to do this. The number 5, that's the stem. Here's the line, and I put the number 6, and that's equal to 56. We do that because what happens if there's a decimal in between? We would draw the stem and leaf plot the exact same way, but the key determines how we read it. Okay, and then we would label what it is, 56%, 56 degrees, whatever. Okay, so our stem could be a single-digit number, or it could be bigger. Okay, but the leaf is always a one-digit number. There's always only one number at a time in the leaf. Okay. All right. So I did some research. I'm a sports fan. I like baseball. It's one of my favorite sports, maybe behind basketball and maybe American football, and no, probably in front of American football. Sorry. Okay. Here is a bunch of data that I collected back in 1997 when I was about 60. My favorite team was the Cleveland Indians, and we played really well that year. This guy right here, Carlos Baerga, was our second baseman, and Jim Thome was our first baseman, and Paul Sorrento played for us as well. But these are the number of home runs that are hit. I don't know what they call them in cricket. Is it like an over or whatever? But okay, so what we want to do, if we notice, the numbers are spread out pretty wide. We've got the number 9, my second baseman, up to the number 58. This guy cheated, so it's okay. We're not going to count him. But we'll still graph his data. One of the things that we might want to do is represent the data in small to big. Okay, but I'm not going to write that out. It's going to be, we're going to flip back and forth. But what we need to do is we first start out by drawing our lines, our 2 black lines. We put our title. Remember to title every graph you make. This one's called Home Run Hitters in 1997. So I go back to the data, and I see my smallest number is 9, my biggest number is 58. So that means everything's a 2-digit number except this. Well, this one can become a 2-digit number. We put the number 0 in front. So the stem is going to be the first number, the tens digit. Okay, you notice I'm only underlining all of the ones that I see that are different. Okay, so I have the number 0, 1, 2, 3, 4, and 5. So what I'm going to do is I'm going to release these numbers, 0, 1, 2, 3, 4, and 5. Now, let me explain something to you. If there were no 10s, if this 18 and this 13 didn't exist, you would still write the number 1 in your stem. Okay? It still has to be there. You don't skip. You don't go 0, 2, 3, 4, 5. Because if that's how you count, we need to send you back to the little kids for school. Okay. Okay, so we have that. And now we want to go back and compare our information. So this is where I'm just going to kind of show you. Okay, we knew the number was 9, so that's why I put a 9 in the leaf. Okay, in the stem, I had a 13, and I had, I believe, an 18. Okay, so I put a 3 and an 8. Notice space, no comma. Okay, the 20s, I had more. I had 23, 24, 27, and 29. So I have 3, 4, 7, and 9. Notice number order, starting from small, moving to big. In the 30s, I had 31, 32, 33, and 35. So I have 3, 1, 2, 3, and 5. I had a lot of 40s. And in fact, I had 3 numbers that were 40. 40, 40, 40, 41, 42, 43, and 45. So we see the number 40, Mike Piazza, Jim Thome, and Jay Buhner. Okay. Now we have our 50s, and that was Ken Griffey Jr. and the cheater Mark McGwire. Okay, 56 and 58. All right. So there is the data represented in a stem and leaf plot. Okay. Now the thing I'm missing is what's under this red box. What's it called? No, it's not called a door. It's called a key. Okay. So I make up an example. Notice there's no 47. So I do 4 with the black line and the 7. That equals 47 home runs. That's what that number would have represented if it shows up in the data. From this data, I should be able to figure out mode, range, median. The mean is always not that great, but you know, good enough. All right. It is possible to do a back-to-back stem and leaf plot where I could compare 2 sets of data. So if I was comparing one soccer league and the highest goal scorers compared to another soccer league like the Bundesliga versus the Premier League, I could do that in one graph. I would have my stem in the middle, and I would have leaf on the left and on the right. Notice you don't write the word leaf, okay? Sorry this is long, I'm done.